3.5 day 2 is a bit of a hodgepodge of things that we're just kind of mopping up at the end of the chapter. And a couple of those things are going to be applications. One application of logs slash exponentials is something we call orders of magnitude. Now, I guess it's not going to be quite an application yet, but in the next example, I'll show you an application of this. So it's kind of a two-step process there. Now, orders of magnitude, there are going to be some questions in the assignment that ask you for orders of magnitude. But as I was looking through the book and reading through the text and everything like that, I noticed that there really wasn't anything that popped out really well. There's only this little excerpt from page 294 that says the common logarithm of a positive quantity is its order of magnitude. So that's kind of interesting. That means that it doesn't tell us much for one thing, but it's saying that if we take the log of a number, now common log being base 10, and we just punch that in, that's going to be the order of magnitude for a number. That's just the definition of an order of magnitude. So some things that you need to know about orders of magnitude is that, for one thing, it's a base of 10. So each order of magnitude, when we're looking at numbers and we say their order of magnitude, each order is going to mean 10 times greater than the next. So something's 3 orders of magnitude greater, it's 10 to the third times greater, or 1,000 times greater. So that's just a little bit of background in that. Let's take a look at an example involving orders of magnitude so you can just see what I even mean by this, because it doesn't make much sense at this point. I'm well aware of that. Here are a couple examples for order of magnitude. It says here, how many orders of magnitude larger is the larger quantity? Well, the first thing that we're going to do with each of these numbers is we're going to find out what is the order of magnitude for each one. Now, the nice thing here is that since these numbers have, like 8 and 8, 4 and 4, you could just say, well, okay, this one's 100 times greater, so it's 2 orders of magnitude greater. But we don't always get numbers that look this nice together. They don't always go that nice together. So what we do first is we just calculate the log of each number. So we'll go the log of 400 and the log of 4. Now, I'm just going to punch this in on the calculator. That's all you really can do with this one, is just say, all right, log of 400. Okay, so that's about, rounding it to 1 decimal place, that's about 2.6. Then we want to do the other one, and that is log of 4. And that's about really, really close, just to 0.6. So how many orders of magnitude bigger is this one to this one? Well, we just subtract those two numbers. 2.6 minus 0.6, that is 2 orders of magnitude difference. And that makes sense because you basically just move the decimal place 2 spots if you go from 400 to 4. All right, now 8 million to 80. All right, so very similar thing. We could write out 8 million with all the zeros. So if you wanted to just count the number of places, you could. But I want to also make sure we're just re-emphasizing the log thing. So log of 8 million and log of 80. Okay, so we go back to the calculator on that one. Log of 8 million and log of 80. So you can see that the first one's about 6.9, the second one's about 1.9. So about 6.9 and about 1.9. So we subtract those and we get an order of magnitude of 5. So it is 5 times greater. The order of magnitude for this one's 5 times more than the order of magnitude for this one. If you want to know how much that is in actual numbers, like what is the amount that's actually bigger, then what you do is you just the opposite. You just do 10 to whatever power this is, that's going to be 100. 10 to the 5th power is going to be 5 zeros, so 100,000. So that's what we're looking at with orders of magnitude. That's just what it means on the surface. We'll take a look next at an example that gives us an application of orders of magnitude.